Today, after finally completing the project I've been working on for a year, I decided to unwind by playing Valheim. Upon entering the game, I quickly create a new character and generate a new map. I engage in combat with the first bush I encounter, finding a sense of calm as I punch the foliage. To meet my initial needs and build a shelter for the first night, I roll up my sleeves and start constructing. I don't want my first house to be sloppy. Taking into account potential threats from the ground, I begin constructing its foundation at an elevated height. Running out of enough wood for construction, I head to the nearest forest with my axe, chopping down as many trees as possible. Utilizing the game's physics engine, I cleverly attempt to use it while cutting down trees. Once I gather enough wood, I turn back to my construction and complete my first home. Treating myself, I add a fireplace to the house. To shake off the fatigue of the entire day, I lie down on my bed and quickly drift into sleep. During the night, I experience a beautiful dream where I see myself creating my own Valheim game, with lines of code flashing before my eyes. This fantastic dream concludes another day filled with pride and happiness from completing my project. When I wake up in the morning, the first thing I do is leave my house and open Unity. I'm starting the project with terrain. Instead of using a pre-made terrain, I want to create a procedural terrain to generate a different terrain for each new game. I add an empty game object to hold my terrains in the scene. Within this object, I start creating my terrains. To be able to start writing the code that will create my vast map, I quickly create a script. After organizing neighboring terrains in the hierarchy, I attach my script to the parent of the terrains and open the script. Since I'll be making edits on multiple terrains, I first create a list to hold these terrains. As I'll be working on terrain data, I define variables to hold the dimensions and height map resolution of the terrain. I also define a variable to hold the height map we will create and set its dimensions. I populate our terrain list from the child object's components. Working with multiple terrains, I set off sets based on terrain positions to ensure different geographies. For the 2D height map we'll use in the 3D terrain, I use a depth vector instead of a height vector. I define a method to generate random geographic shapes and start writing code to create the geography using Perlin noise. I write nested loops to fill our 2D height map array. To achieve a more realistic geography, I plan to use multiple Perlin noise functions. To reduce the power of the generated Perlin noise, I update my scales list's y vector as a vector 2 instead of a float array. I define the heart of the entire script, the getPerlinNoise method, which fetches height information for each pixel in the height map. As I will use multiple Perlin noise functions, I increment the previous value with the new value for the height map. Now that I have height information, I can transfer these details to the terrain. Turning back to the Unity screen, I organize my project files again. When I run the application to see the results, I encounter an error due to missing scale values. After quickly making my list accessible, I input the values and run the application again.
It was at this moment that he knew. He fucked up.
Repeating the same mistake I never seem to tire of, I inadvertently send the application into an infinite loop and crash it. Returning to my code, I iterate through the loops again. Upon running the application, I see random shapes on the terrain, but it resembles more of a lasagna than geography. Checking my code, I realize I've inadvertently shifted the Perlin noise in the wrong direction. Consoling myself with the fact that no code is written without errors, I run the application again. And now the terrain looks more like a diverse landscape than lasagna. Adjusting the dimensions, I strive for a better result. Since our terrain is not colored, the obtained results don't look visually appealing. Therefore, I import the Procedural Terrain Painter package I previously used into my project. Additionally, to use the terrain layers of terrain tools, I add this package to my project as well. Adding the Terrain Painter script to the parent terrain, I include active terrains in the script. Realizing that Terrain Tools terrain layers are in the Terrain Sample Asset pack instead of the Terrain Tools package, I import this pack as well. I'm trying to achieve a more realistic geography by adding Terrain Painter to different layers. I set height conditions for the added layer, allowing the texture to paint only up to a certain height. To better visualize the game screen, I slightly adjust the camera angle. Also, I set the height of the mud layer to a value that looks pleasant to my eyes. To emphasize the height of the mountains, I add a snow layer and adjust its minimum height to 200. Since the grass layer falls below my expectations, I replace this layer with a different texture. As I don't like the transition from mud to grass, I also want to add a sand layer with a slope condition to make it more even. While I have found the slope condition, I add a rock layer to give a rocky appearance to the steep slopes of the mountains. I adjust random values until I achieve the desired look. To assess the performance of the layer, I make the geography steeper and observe the layer. Since the Terrain Painter script works in the editor to avoid runtime issues, I manually call the repaint all method of the Terrain Painter after creating terrain. To enable painting, I recalculate the bounds as knowledge of the terrain bounds is necessary. To use the Perlin noise effect after certain heights, similar to Terrain Painter, I modify the scale type to vector 3 and use the z-axis as the height condition. If the height of the height map exceeds the specified height, I calculate the height with the values provided. I want to rearrange the height conditions and test the new code I acquired. However, upon changing values and running the game, I realize I've broken something again. Upon reviewing the code, I realize that I didn't check for equality in the condition, causing an issue since the height map is consistently 0 in each loop. To avoid repainting after each terrain creation, I set up the painting process to occur after all terrains have been created. Since our script only runs at the start time, requiring the game to be restarted each time to see changes, I move it to the update method for faster results. Since editing 25 terrains every frame can strain the CPU, I move other terrains outside the parent and only observe one terrain. As I decrease the Y value, I can achieve steeper slopes. Thank you for watching my video. I plan to turn this into a video series and create a playable game. If you want to see more, you can support me by liking the video and subscribing to the channel. Feel free to leave your suggestions and requests in the comments. In the next video, I'll be creating an ocean system, which can potentially cause serious performance issues. I'll implement this system not with shaders, but with mesh deformation, allowing objects to float on the surface. By the end of the episode, I'll demonstrate how to make objects float on the ocean without continuously taxing the CPU and memory with a constantly undulating ocean.